Dependency injection is a mainstay in the static languages, but does it make sense to use it in Python? Will it make me a better Python programmer? And wait, what is dependency injection again? In this video, we answer these questions. Hi, I'm Chuck. I've spent 3 decades as a software engineer. I share my insights and combine my experience with AI to create elegant solutions. Let's get into it. First, let's answer the question, what is dependency injection, or as sometimes it's referred to as just DI? Dependency injection is a pattern that, when used, moves the construction of an object outside of the class. Instead, the class takes a dependency on an abstraction. In static languages like C# and Java, dependency injection is heavily used to reduce coupling and facilitate testing. In fact, you'll find dependency injection frameworks whose sole purpose is to maintain dependencies and their relationships to each other. Dependency injection has 2 purposes. First, it reduces complexity by taking a dependency on an abstraction. We'll look into that a little bit more. Second, depending on an abstraction allows different implementations, including mocks for testing, to be passed into the class, or could even be a function. So let's look at some code and look at how dependency injection changes the code. So in this first example, you have a user class. It has a constructor. There's a local variable, class variable called database, and we're creating an instance of a SQL Server database and setting it to this database variable. Then there's another method that is called getDetails, and it's using that instance of the database, the variable. So this is straightforward code. This would not be out of place in any Python code base. But let's look at another example, taking this code and applying the dependency injection pattern to it. So this is the same class. It's called user. It has a constructor, has a getDetails function or method because it's a class. But the difference here is that we have a parameter called database that is typed database, and then we pass the database parameter into the constructor, and it's set to the self.database class variable. This is dependency injection in its simplest form. I mean, it doesn't even get any simpler than this. While the concept is straightforward, passing a parameter into a class, its power lies in enabling flexible designs. Let me demonstrate this flexibility with another example that shows how we can switch between different database implementations on the fly here. So let's get rid of this code. Goodbye. Hello, new code. I'll walk through the code line by line. Date string, line number 1, this is just a date. Line number 2 is format. Number 3 is actually formatting the date by the format that we just defined so that we can get a date object. And then turn of the century is a date object of, the first day in the year 2000. So the first line is kind of where things get, where things start happening here. Line 6. Line 6 is where Postgres, we're taking a Postgres implementation, we're setting it to the database local variable. We're going down to the next line, and we're checking to see if the birth date that we said earlier is less than turn of the century. And if it is less than turn of the century, we're going to use the SQL Server database. If it's not, we're not going to change the database parameter at all, and which is, remember, it's set to Postgres. And we're going to continue on with Postgres database. And then, the user class, again, the second implementation we saw, we pass the database into it, and then the user calls getDetails and gets the user information. So this is the power behind dependency injection, is it allows us to swap implementations easily based on different conditions. While this functionality is valuable for production code, one of the most common use cases for dependency injection, especially in static languages, is testing. So a word before we move on to the next example is, as long as the Postgres database, SQL Server database, and whatever else database you want to use implements the database abstraction. There's a database class called database that these all inherit from. As long as it implements the right methods and returns the expected results, this user class doesn't care what database it's coming from. It doesn't care. It could be a flat file. It doesn't matter. It just knows that it calls the getDetails method, passes in a user ID, and gets a result back. And that's all it needs to care about. Let's look at an example of dependency injection being used in a test. Let's just give her this code. Goodbye. Look at a new code. This class is called user test. It is your typical test in Python using the built-in or the framework that comes with Python. Here, in the previous examples, we had a Postgres database implementation. We also had a SQL Server database implementation. In this example, we have a mock database. And again, the mock database implementation inherits from the parent database class and implements the expected behavior on that abstraction. We could also use the built-in mock class in Python to achieve the same effect. But I wanted to demonstrate the power of subclassing. And so we take the database variable and pass it into the user. In this example, we're calling it is authenticated method. And then we're checking that it's true. But this is the beauty of dependency injection, and this is what makes it so powerful in static languages. The user doesn't have or doesn't know the concrete implementation. It simply takes a dependency on the parent database class. And then whatever instance is passed in is what it uses. Interestingly, when I started learning Python a few years ago, and I joined a company where Python was a pretty big language, dependency injection wasn't widely used in the Python projects I worked on. Coming from a static language background, I was surprised, and it seemed counterintuitive, and I was, to be honest, a little appalled. I was like, this is a great pattern. Why is this not being used? However, as I learned about the language and how to use it, there's a reason for its limited adoption. Python's built-in patch functionality already provides excellent testing capabilities, eliminating one of the dependency injection's main benefits. Now, while dependency injection can still help by reducing complexity, there are other patterns and approaches that can be taken to achieve the same goal. I'm not saying that dependency injection shouldn't be used in Python. I think it's quite the contrary. Like all tools and patterns, there's a place and a time to use them. And dependency injection is just another tool in your toolbox that will improve the quality of your code. I think dependency injection will generally increase the code quality in most projects. If you're interested in exploring dependency injection further, I recommend checking out two popular Python frameworks. The first one is called Injector, and I'll put the link in the description below. The second one is called Dependency Injector, and again, I'll put the link in the description below. If you found my video helpful, please hit the like button. It helps others find me and it supports my channel. If you're new to the channel, consider subscribing. I'd love to hear about your experiences with Python and dependency injection. Please share your thoughts in the comments below or connect with me on social media. All my contact information is in the video description below. Thanks for watching. Stay curious and keep learning.